So we are discussing software engineering, and the book we are following is Dr. Pressman's book of software engineering. So what exactly this software engineering is? Who does this software engineering? Why is it important? What are the steps? And what is the work product? So what is it? Computer software is the product that software engineer design and build. So a software engineer, just like a civil engineer, builds, say, bridge. An electronics engineer, he builds say a gadget or a device, a designer device. In the same way, software engineer, they make software. And by making software, we are assigning that he builds and design the software. So it also includes the program which a computer is going to execute, and that can be of any size or architecture. The architecture can be MVC, model view a controller. It can be two-tier architecture. It can be three-tier architecture. And also the document or the hard copy and virtual forms. Then the data that combines the numbers and text, which may be included in some pictorial, video or audio of information. So computer software not only consists of code, but code along with all these means the documents and all the supporting materials. We call it as a software. So who does this software engineering? Software engineer they are involved in it, and virtually everyone who is related to the software, you can call it a stakeholder or the person involved or the users, all have interest in it. Why it is important? Because making a software, like for example, railway reservation. While you're doing this railway reservation, someone is making this software for someone, may say for government, some company is making, but it is directly related to us in every individual. So it is nearly always affecting our life, and some or the other way it is connected. So what are the steps? These steps means you have an intention to give your user a usable, a high quality, and the cost worth product. So these are the steps you take. So whatever you do, these steps we'll see in detail in this course. But the steps or the idea or the agenda is to make a quality software within budget, within cost, and within the timeline. So what is the work product? As I said in the software terms, the programs, the documents, and the data, all these combine to form a computer software. But in terms of the user's viewpoint, the work product is something which has made his world better. So what is software? Software is instruction or computer program, computer program in any language of your choice. C, C++, Java, C#, C#, or any of your choice. So instruction that these are the instructions when executed, they provide certain features, functions, and performance. And the second part of software is the data structure that would enable the program to adequately manipulate the information. And finally, the documentation that describes the operation and use of the programs. So all these three, 1 + 2 + 3, is your software. Software is developed and engineered. It is not manufactured. The way we manufacture any goods, which is tangible, means you can touch it, you can feel it. Software is developed or engineered. It cannot be manufactured, and software doesn't wear out. This line we are going to take many times in this session, in coming session also. Wear out means software is not hardware that a car you buy, or a laptop you purchase. Laptop will have a life of say 4 to 5 years, or 4 years rather, depending on the battery and the configuration. And the car, say a very good car you have taken, and 4 to 5 years again the life of the car, a good car. But after these years, the problem starts. But software has no problem whatsoever. It doesn't wear out. And the industry is moving towards the component basis construction. That means take component 1 which is already built, take component 2 which is already built, combine them. Because they have already been built, they have already been tested, they have already followed the software engineering paradigms. But we are going towards component based construction, but still most of us, they make software which are custom built. This is the wear versus deterioration. See, a hardware, it follows a bathtub curve. What it means? That in the initial inception, when it is incepted, because it is new, so wearing, tearing chances are quite high. But as you start using it, after a certain time, if it has not given any problem, then of course, for a stipulated time or for a life, it lives like a plateau. And after that, a certain period of time, it shows the deterioration. So this is the deterioration with time. What about the wear versus deterioration in terms of our software? The failure rate and time, as we have seen in the hardware, which is the bathtub curve. It is showing bathtub curve. Initially, the wear or the deterioration may be large, but after that, it reaches. This is the idealized curve, but it doesn't happen like this. What happens is, you start, and then after a certain time of period of time, there is no wear and tear, but the changes are required, and that will increase failure rate due to side effects. Then these are all the changes, and the actual curve of failure rate would increase with the number of changes being employed. There are various software applications, various categories, but we can broadly categorize them into system software. Like the operating system has their own system software. Application software like your MS Word, etc. Engineering or scientific software like what do I say? Making like some software in Fortran you have made, or any specific work it does, means knowing the location of the celestial bodies. Then the embedded software, maybe in certain device or your washing machine, or even in your mobile. Product line software, web apps, web application, they are so much used, employed, and worldwide ubiquitous. Then we have artificial intelligence software. So these are the 7 broad categories. And the new categories which are evolving in the software, they are open world computing, that is the pervasive distributed computing, open source or open world computing. But this is open source is different, open world computing is different. Open world means it is distributed among the various nodes or position in the world. Ubiquitous means wireless. Everyone in the globe can access. Net sourcing, a web used as a computing engine, say for cloud computing, this can be a very good example. Cloud computing, what the software as a service, infrastructure as a service, and these services are provided by cloud. So if you ask for a software or a space or a computing, then you will get a computing on present payment basis, and now on the web you can do your computing without even buying or purchasing hard or very high-end software or hardware, etc., or even the space. Open source, free source code open to the computing community, and also the data mining, the grid computing, the cognitive machines, the software for nanotechnologies, all these are budding technologies, and now it is gradually getting more pronounced and proliferated. What about the legacy software? Why we are talking about the software engineering? The older programs, often known as the legacy software, has been the focus of continuous attention and concern since 1960s. Danny Farr and his colleagues, they described the legacy software. They say that these software systems, which are called as a legacy software system, they were developed decades ago, and they are continuously modified to meet changes in the business requirement and computing platforms. And the proliferation of such system is actually causing headaches for large organizations. Why? because to maintain and the risk which it involves is quite costly. Then Lee and his colleagues extended this description by stating that many legacy systems they remain supportive to core business functions still, and they are indispensable. Means they have no other option, or they have no other software that can take place of these softwares to the business. Hence, this legacy software is characterized by the longevity and business criticality. So, if you are asked about legacy software, you will be concentrating on the longevity and the business criticality, right? Legacy software, because we are actually taking step toward reaching that software engineering, why we are into it. So we need to talk about all these legacy software crisis, etc. So why must it change legacy software? Since we have new computing environments, technology, so to meet these various trends and changes, a software needs to be adapted to these trends. And because we have new business requirements also, not even the technology, we have business requirement also. For that, the software must be enhanced to implement these. And to make it interoperable means there are various platforms, operating system configurations available, more databases, modern systems have various other things which are involved. So you need to make that software interoperable also. And re-architected. Now the architecture has changed. See, previously it was HTML. You need to talk to web server, and if you want to talk to from any other position, you want to actually talk to one say domain or the area, you are not able to talk because the configurations and sophistications are different. Now you have web services. They are interoperable. So in these two, both the parties can easily call web services and consume web services. So the architecture has changed. The network environment has changed. We need to change. And because the web applications have so much impact on the present scenario, because web application now, the desktop application, they are changing to the web application scenario, or these software are built from scratch in the web environment only. Though some softwares they will not be able to web app, means they will not be web app. There will always be the desktop softwares, But the basic idea is the internet cost going less, the availability of internet and the data services becoming more and more. The companies fighting and striving. So web apps are so popular. There is no problem of the latency or the computing on the web. So the characteristic of web apps are they are network intensive. Means a web app reside on a network and must serve the needs of a diverse community of clients. You have a web browser. It's a very small program, and this is the only client you have. And web application runs on this browser. It can be Chrome. It can be your Safari. It can be your Firefox. Network intensive. So concurrency is also there, because when number of users are using their browser and at the same time they are accessing some data, concurrency will always be an issue. The unpredictable load. Since you have say a single server, I'm just naming it, because for sites which are for the applications which are not used by many people, like say remote sensing software, it will not be used by everyone. But if a software is a school software, a basic school software, most of the people would like to use it, because schooling, it is so obvious and so distributed and known. And most of the people are involved in teaching and related stuff. But remote sensing, they are specialized people. So this unpredictable load, if you have only one server, it is okay. If say Facebook or your Google has only one server, whether these giants are able to handle this load, may not. They may not. The performance. Nobody would wait. If he has opened something, it takes time, he will jump onto some other options because there are a number of options available. The performance is an issue. The characteristics, I'm not saying that is an issue, but these are the characteristics of web apps which need to be understood. The availability. Again, let me come to the Facebook. Orkut was replaced by Facebook. Now say some other X has come. No. People have thought about it, but they are not going to X, but they are just sticking to FB. Say FB is down for 2 hours, and now it has shown, Facebook has shown this trend that it can go down anytime. I'm sure most of the users would go to X if X is performing or giving more functionality than Facebook. So 24/7, 365 basis, 100% availability is what is required for web apps. Web apps are data driven. The primary function of many web apps is to use the hypermedia to present text, graphic, audio, video. Now we have HTML5. Now in HTML5, you can embed your audio, video, or even you have a canvas. In this canvas, you can show the web through WebGL. You can show the 3D. So it is data driven. It is content sensitive. The quality and the aesthetic nature of content will actually define is the quality of the web app. I'm sure you might have come across 2 websites. One is very flashy, looking good, and have very smooth transitions, and one is just not. The colors are not used good. It is static. You can't interact. Where are you going to go? Of course, not for the second one. Continuous evolution means, unlike conventional application software that evolves over a series of planned, chronologically spaced releases, web application, they evolve continuously. Because web app cannot follow a waterfall model or a spiral model. These are the model we are going to discuss in detail. So a web application may not use this model. They have a different scheme of development, and they are evolving continuously. So you can call them as evolutionary type. Okay, you may try to fix or implement some or the other model to this. Then the other is immediacy, means the software market is changing. Every time new domains are coming, your competitors, they are coming up with various new innovations. So there is always immediacy. You have to do it immediately, in no time. If you lose even for 1 day and somebody releases the other one and it gets hit for for 1 day, and people have just downloaded their software or they have registered, then you are nowhere in the market. The security. Web app is available via network access. So you have a web browser, you are connecting through internet, or in the client server application is via network access, you are doing client server communication. So what about the security? How you are going to ensure the security? For this, you have to see that firewall is up. You have to see the proper protection and security aspects are in place. The authentication authorization needs to be seen. And also, after all these things, the security also need that encryption has to be done. Then the aesthetics, look and feel. The most important part of software is web apps is how does it look. So there are some certain realities in software engineering. There has to be a well-planned, dedicated effort first to understand the problem, because it is not that you will be told step 1, step you go for step 1, step 2 you go for this, step 3 you go for this. No, there is a problem which is posed in front of you, and that problem being posed may not be even clear to the user himself. He is not a software maker. He can only tell you that what exactly is going on. And you have to understand in the terms of the design and the coding and the maintenance. So it needs that you understand the problem. Their design becomes the pivotal activity. The design will decide the success and failure of your software. The quality of the software should be very high. That is customer satisfaction, conformance to the standard, and the user satisfaction. All these things has to be there. Maintainable. Most of the time goes in maintaining. Once you have deployed the software, you take the cost of the maintenance also. You charge them, because the other person or other company, they are not into software making. If they want to change something, how they are going to change? They will come to you and you have to maintain it. The definition which was proposed by F.B. Fritz Rosser, he says that software engineering is the establishment and use of sound engineering principles. And these engineering principles came from civil engineering, where you make a bridge and it lasts for 100 years. And these application of use of sound engineering principles in order to obtain economically software economy or cheaper software that is reliable and work efficiently on the real machine. And this is a very, very good definition. The IEEE, on the other hand, they introduced the application like the software engineering is the application of a systematic, disciplined, quantifiable. Please understand, if you are about to give this definition, you have to write this definition. You may learn like this as DQ. So the application of systematic, disciplined, and quantifiable approach to the DOM, development, operation, and maintenance of software. That is the application of engineering principles or engineering to the software is what we call as software engineering. We have a layered technology in software engineering. That means first is we have, this is a bigger plate. The main focus is the quality. Then we have process models. What process models you are going to adopt? Means say SDLC models. So you are going for iterative model. Just an example. The methods which you are going to adopt and the tools like case tools or any other tools which are related to the software engineering. So this is a layered technology. Any engineering approach which is software engineering also now must rest on the organizational commitment to quality. So this is the largest plate on which everything would be built. Total quality management, Six Sigma, and other similar philosophy foster a continuous process improvement culture, right? So process defines a framework that must be established for effective delivery of software engineering technology. These processes, as I said, these are mainly processes. And software engineering methods, they provide the technical know-hows of how you are going to build the software. And finally, the tools, that is, how you are going to automate or semi-automate, or you can get the support of these tools to support the engineering processes and methods in the software engineering. So what exactly is software process? So software process, it is a collection of activities, action, and tasks that are performed when some work products is to be created. Software process. And we have talked about a process as a collection of activities, actions, and tasks. You can add them. Activities plus action plus tasks, these contribute to a process. So when these three are applied, some work product is to be created. So what exactly this activity, action, and task means? An activity, it strives to achieve a broad objective like communication with stakeholders, and it is applied regardless of the application domain. It will be there for every problem domain or application domain, or even for any size of the project, the complexity of the project, or degree of rigor with which software engineering is to be applied. So it is a broad objective, you can say an umbrella activities. Then the action means what is the design you are using. For example, architectural design. So these are the set of tasks, the action are the set of tasks that produce a major work product. Like an architectural design model, the architectural design will give rise to architectural design model. Then the task focuses on a small, well-defined objective, like just conducting a unit test. So it is a task, but it is well-defined. It is small, but it will produce a tangible outcome. You can, their output is in front of you, so that the decision can be made of it. So there, the generic process framework for software engineering, it will encompass the activities of communication, the planning, the modeling, the construction, and the deployment. In the modeling, we analyze the requirement and then we design. And in the construction phase, we generate the code and we test. So these are the various generic process framework of software engineering people generally follow. And whichever model you take, whichever way you take, it has to go like this to make a good software. And umbrella activities means this is an umbrella. Okay. And your software is to be made here. So there is an umbrella which is always there on your top, which starts from here, ends here. So it will save you from all the rains and showers, etc. So what are these umbrella activities? These are software project management, the risk management, the SQA or software quality assurance, the FTR or formal technical reviews, the measurement, the SCM or software configuration management, the reusability management, and the work product preparation and production. So software engineering process is not a rigid prescription. That means if you have to make a good or a machine, the process should follow a rigid prescription of size, length, micrometer, millimeter, etc. But in software engineering process, it is not rigid. It should be agile and adaptable, that is amenable to change. So a process adapted for one project might be significantly different than a process adopted for another project. And the differences are the overall flow of activities, actions, and tasks, and the interdependencies among them. First of all, then the degree to which actions and tasks are defined within each framework activity. The differences I am talking about, the degree to which the work products are identified and required, the manner which quality assurance activities may be applied, the manner in which the project tracking and control activities would be applied, and the overall degree of detail and rigor with which the process is described, and the degree to which the customer and the other stakeholders they show involvement in the project, and what is the autonomy of the software team, and how the degree to which team organization roles are prescribed. How to solve it? It was the classic book written before modern computers existed. So Poila outlined the essence of problem solving and resulting the essence of software engineering practices. And the person said that first we need to understand the problem. That is, the communication and analysis needs to be there. Then understanding the problem, after that, unless and until you understand the problem, you cannot go to the other levels. Then you have to plan a solution. That is, you have to model and software design. Then you have to carry out the plan. This is the plan being made just now. So you have to implement that plan. And then the accuracy, of course, testing and quality assurance. So you have to examine the result for accuracy. What is understanding the problem? How do you understand the problem? Understanding the problem means you have a customer and you are making a software. Customer has come to you. He has posed you the problem. So how you are going to understand the problem? Who has a stake in the solution of the problem first of all? Who are the stakeholders? What are the unknowns, data, function, feature which are required to properly solve the problem? Can the problem be compartmentalized? Means, can it be made in smaller problems that may be easier to understand? Can the problem be represented graphically? That can an analysis model be created? Like people generally make UML diagrams and DFDs, etc. Then how to plan the solution? Have you seen a similar problem before? It is okay. If it is there, use it. Has a similar problem being solved? Yes, use it. Can sub-problems be defined? Yes. Okay. If can be defined, if so, the solution is readily apparent for the sub-problem. Can you represent the solution in a manner that leads to effective implementation? That means, can you make a design or model out of it? How to carry out this plan? Does the solution conform to the plan? Is source code actually traceable to design model and design model is actually traceable to the requirement specifications? Is each component part of the solution probably correct? Means the design and the code being reviewed, or better, they have correctness proof that is being applied to an algorithm. Then we can examine the result. Is it possible to test each component part of the solution? Because we need to have a reasonable testing strategy which needs to be implemented. And then does the solution produce results that is actually conforming to the data, functions and the features that are required? Means, have you validated against the stakeholder requirement? So David Hooker has proposed 7 principles that focus on software engineering principles of practice. He said, first, the reason it all exists, that is, there has to be a problem for which you are this problem domain for which you want to go to the solution domain. KISS means keep it simple, stupid. Always make things simple. Always have the vision and maintain it. And what you produce, the other is going to consume. So just put that salt which is eatable, or the sugar which is drinkable, not more than that. Be open to the future means just assume that you are going to be showing amenability to the changes, and make this reuse possible because you are going to use it again. And think, always think. There are software myths, that is misleading attributes that have caused serious problems for managers and practitioners alike. For example, they are affecting everyone. They affect managers and customer and other stakeholders, of course, and practitioners. And they are believable because they have certain element of truth. But it will lead to bad decision. So, insist on reality. You navigate your way through software engineering. So, how it should start? Every software project is precipitated by some business need. Some problem has to be posed in front of you with certain money that you make this and we'll give you money. So, the need to correct a defect in an application, correct existing application can be there. Or the need to adapt to a legacy system to a changing business environment, and the need to extend the functions and features of an existing application, or altogether you are creating a new product or service or system. So you see, creating a software or new product comes last. So people, we generally think in software engineering, we are making a new software and we'll apply this software engineering. But it is not the case. There are legacy systems, there are systems which are already been made. So for that, you need software engineering practices. So all these three, please read them again, because this making of new comes last. Thank you so much. This was an introduction of software engineering, and we'll be taking more on software engineering based on Pressman's book. Thank you so much.